My name is Akintola Akintoye. I'm the Dean of School of Built Environment, Engineering and Computing. Normally, this event should be chaired by the Pro-Vice Chancellor Research, Professor Seka McCold, but she's not here today, so she has sent her greetings to Professor Saheed Ajayi. And also, it's good to welcome each and every one of you here. And specifically, I would like to welcome Professor Charles Hegu, the Vice Chancellor of Leeds Trinity University, is here with us. Also, alumni of Leeds Beckett University as well. So, thank you for coming over. It gives me great pleasure to welcome you here to Leeds Beckett University and to the professorial inaugural lecture of Saheed Ajayi, Professor of Digital Construction and Project Management from the School of Built Environment, Engineering and Computing. Professor Saheed is a highly regarded authority in digital construction and project management. He has held diverse roles from the construction sector and academic institutions, including Director of the Construction Informatics and Digital Enterprise Research Laboratory. In his inaugural professorial lecture, Professor Saheed will delve into the world of construction and sustainability, drawing from his extensive experience and groundbreaking research projects to highlight the crucial role of industry collaboration in driving digital transformation within the construction sector. Saheed will explore his world of cutting-edge research interest, including building information management or modeling, sustainable construction, and construction informatics. Delving into extensive project portfolio, it will uncover government-funded projects and showcase the real-life impacts of his applied research. Using examples from the collaborative and multidisciplinary research projects with key players in the UK construction industry, Saheed will also share his commitment to bridging the gap between academia and practice. This lecture is part of the Leeds Beckett University's inaugural professorial lecture series. It is my pleasure to now invite Professor Saheed Ajayi to present his professorial inaugural lecture titled Constructing the Digital Symphony, Orchestrating Collaborative Innovation Towards Sustainable and Productive Construction Industry. Thank you, Saheed. Please come.
Thank you very much, Professor Akintola Akintoye, and thank you very much, everyone, for honoring me with your presence at this occasion. I'm truly honored. Professor Akintola was saying that it's a big one, which is really interesting. Thank you very much for coming around. Today I'll be taking you through the journey of my research that I've been doing over the years on digital construction and other aspects of my research that I've done over the years. I will start by explaining some of the concepts that are in that topic. Going back to that, there are key concepts here. We have the digital symphony, collaborative innovation, as well as sustainable and productive construction industry. I will start by talking about these three quickly, then before moving to the different research projects that I've done over the years. So you can just imagine when we look at the other fields, apart from construction industry, like the field of medicine, what could happen if there is not collaboration between academia in the field of medicine and the doctors themselves? What do you think will happen? I think if there is no collaboration, let's take COVID as an example, there will be chaos. So we won't get out of COVID up to this point in time. So that is showing how academia and industry collaboration could prevent chaos that could ensue because of poor collaboration. So just imagine it. You realize that there is going to be chaos if there is no adequate collaboration between industry and academia. And that is not just for the medicine, for the field of medicine. for every field, if people in academics do not collaborate with people in the industry, what happens is that the research project will just end on the bookshelf. Nobody will use those outputs. So the synergy between academia and the industry is what will lead to groundbreaking innovation. And that's exactly what my research is all about. My research is all about collaboration between the academia with the researcher and the industry partners, the industry stakeholders who are going to make use of the research projects that we are carrying out in the university. So the future is multidisciplinary. There's no doubt about that. So you realize that most of the groundbreaking research are things that are done in collaboration across different fields. And that is exactly what I've been doing over the years. Looking at the framework here, so this is what illustrates the kind of research that I've been doing over the past few years. That is what we regard as participatory action research methodology, where industry stakeholders and the researchers are going to collaborate to ensure that we solve real-life problems and challenges that are facing the businesses. Ideas, we conceptualize the ideas. We have ideas. What we do after that is to approach the industry partners, to tell them this is what we are thinking of. We know that you have this particular challenge, and this is how we think this could be solved. So after meeting them, they give us feedback as well. That, okay, you understand some of the problems that we are facing, but we even face more problems than you think. So they give us feedback, and that's what you see in the number 3 here. That's a further need analysis. We analyze the needs in collaboration with the industry partner. Then we are going to develop our research implementation plan. This is what we want to develop. So again, we get feedback at this particular point before we then develop solution for them. That's what you see in number 5 here. We develop the first stage of that innovation. Then we move on to test it in the real life with the industry partner to see how that is going to work in the industry. So it's iterative processes. We follow this approach to ensure that we develop solutions that are going to solve industry problems. And using this collaborative approach, I've worked with different collaborators across the UK construction industry and even outside the construction industry. As you can see here, it's a pleasure to see some of the past collaborators and current collaborators here as well. You can see different organizations that I will not bother to mention. You can see large construction company, SME. We have small organization as well that I've collaborated with over the year. And that is the essence of collaboration. Collaboration helps us to make sure that research projects, we analyze the needs of the businesses. We understand their needs, and then we engage them earlier in the processes. We engage them earlier to strengthen the problem that we identify, and that ensures that we are going to be able to put the research into use. It's not just going to be research that is going to end on the bookshelf. It's not just going to be jargons that we just put in academic publication, but it's going to be something that is going to be very beneficial to businesses, solving real business challenge that are facing organizations. That is the first part. That's about the collaboration. The second part of this is productivity and sustainability in the construction industry. If you ask me, that is construction industry less productive when compared to others? Is construction industry less sustainable? The answer is definitely going to be yes. There are a lot of analysis that have been done about the productivity of the construction industry. Government has constituted a lot of reports, and according to McKinsey analysis, they suggest that if construction industry could be as productive as other industry, the industry is going to be making profit of £1.6 trillion every year, in addition to the current profit. So construction industry is less productive, the profit is less compared to other organizations, other industry. Also, when you look at the construction industry in terms of sustainability, so we are not doing very well. We are making effort in the construction industry, but the sustainability of the construction industry is very, very important to sustainability agenda of the world itself. And when you look at the material that we consume, construction industry consumes about 50% of everything that is excavated in terms of material. We generate about 44% of waste that is going to landfills and several other things like that, which is showing us that construction industry needs solution that is going to assist the industry to be more sustainable We face a lot of challenges in the construction industry, which my research is addressing one at a time. Looking at it, construction industry is the most dangerous industry when you compare it with other industries in terms of the death on construction site. The collaboration is not really great. We have a lot of challenge with that. Low productivity, predictability. Everybody knows about HS2 project, how it has been delayed. So that is just an example of what is happening in the global construction industry. Not just the UK, when you go to other countries as well, we have project, we want to finish the project. We know this project is just 2 years project. We finish it in 2 years. After 3 years, you still realize that the project has not finished. So these are some of the challenges that are facing the construction industry that my research is addressing. The third element is the digital symphony. Why digital? Why digitalization? The UK government, through the Construction 2025 agenda, recognizes digital technology as enablers for the construction industry. They believe that through digital technology, the use of building information modeling, which I'm going to explain for those that are not from construction industry later in the process, the use of BIM, building information modeling, and digital technology is going to help the construction industry to lower cost by up to 33%, to reduce emission by up to 50%, to ensure that the project are delivered 50% faster. That is, 4-year project could be delivered in 2 years if we adopt digital technology. And that is the essence of my digital technology approach to research. And in addition to that, looking at the figure on the right, that is from McKinsey Global Institute analysis, construction industry is second to the lowest when it comes to digitalization. The only industry that is doing worse than construction industry is the agriculture. So all other industries are doing better than construction industry when we talk about digitalization. And that is why going to digitalization in construction industry is something that is very, very important. It's something that could have significant impact on the productivity, profitability, sustainability, and safety of the construction industry. So these are some of the things that inform my research, which is into industry and academia collaboration first, because without collaborating with the industry, there's no how you can understand the problem that they are having. We can just understand it on the book, but the actual challenge, we cannot solve it without collaboration with the industry. And in addition to that collaboration, I then apply digital technology because that is an enabler. That is what is recognized as being very important to solve challenges that are facing the construction industry. And that is what I believe is going to lead to sustainable innovation in the construction industry. This is basically the introduction to that topic and the approach to my research. Using this approach, this is just a bit of highlight of what I've achieved over the just few years of research. I've got about 100 publications, over 100 citation, the H index of 33. That is just for people in academia anyway. So we have, I've executed more than 20 government-funded research projects, total value about £8 million. And when you look at that, I'm very proud of that. That is the research that I've done between 2014 and 2020. I was actually ranked number 8 globally in that research area. So, and all these are not something to boast of, but something to recognize people that have helped me to achieve that. This will not be completed without me mentioning my boss. So that is Professor Lukman Oyedele. So that is my PhD supervisor. And that is what I wrote in my PhD thesis some years back. Towards the end, you see, I wrote that he has not only given me fish to eat, but he has taught me how to catch big ones. That is from my PhD thesis. And the training from him is what has kept me going. So I think it's very important for me to start talking about my research by recognizing the person that has contributed significantly to that achievement. He has done very well, and he has been the one that set me on that track that I am. And looking at it, it's been a short journey to professorship compared to many people, and that is because of the training that I've received through him. So that is what I wrote some years ago, and that has really been the case in terms of achievement. And that achievement, what he has done is not even going to be, it's not going to look significant, because you will think it's only me. So these are the people I did my PhD with at the same time, just some years ago. So all of them, the 4 of them, including myself, all the 5 of us, all professors today, and that is just less than 10 years in terms of this achievement. So these are the people that I've started my career with. We collaborated, we published together. You see Professor Akinade, I think he's on his way, he's currently in Teesside University as a professor. The B, see Professor Wolabi there. He's also in University of Bolton as a professor, Professor Hafiz, University of Hertfordshire, and Professor Bilal, also in Birmingham City University. All of them professor, and the greatness of a man is just going to be measured by how many people the person has also made to be great. So he has done very well, and these are the people that have contributed significantly to my research career. And that is not all. So I've also worked with a lot of people, a lot of mentors, a lot of collaborators, people that have given me advice. You see here, I don't want to mention everybody, but definitely you see Professor Arif, who was my external examiner for PhD. So he has been mentor since then. We have Professor Akintola here. We have my boss, Mark Wilson here. So his name is there. So that is the person that gave me the opportunity. Yeah, he has been very, very supportive, and other colleagues within the surveying, construction, and project management. So these are just a few of the names. That is Ash. So the name is there. That's Professor Delaimi, and several other people. People have worked with me in my lab as well. I have researchers. All of them have really helped me to achieve all those things that I've mentioned. So, and most importantly, we have family and friends who have also supported me. So that's my wife there. She has been a pillar of support, and also the children and friends that have been supporting. So it's been really great to get to this point with their support. So after that, just walk through what has been my research areas, my research achievement, and the contribution. So I divide that into 3. I have my pre-PhD research. So these are the projects that I've done even before starting my PhD that led to publication later on in the process. About 6 publications from that area, which is just things that I've done before PhD. And then the PhD research into waste management, which earned me that number 8 in terms of the ranking in that research area. Then what I've been doing after PhD as in joining Leeds Becker University in terms of the digital construction. I'm going to talk about them quite briefly, then I will use examples of projects that I've executed to illustrate them. The first element is the research into life cycle analysis. So life cycle analysis for the whole building is to evaluate the impact, the environmental impact of building over its entire life cycle. Whether that is a building that has been constructed or building that is about to be constructed. We have methodology for evaluating the whole life impact to know how we can optimize it to ensure that building is going to have less impact on the environment. And that's involved evaluating the impact of the materials that are going to be used for that building, evaluating the construction processes, evaluating the operational phase of the building once it is delivered, how do they operate it. So I did research into here, and some of the key things that I did there is to look at the relationship between building sustainability and building health. Are sustainable buildings contributing to the health of the building occupants? So I carry out some research here, and some of the findings here is that looking at the different materials, we are very lucky in this part of the world. The timbers being used in buildings, so they are the most sustainable, especially if you are going to use soft timbers for construction. Also, there is positive correlation between building sustainability and building health. So that is one of the key elements there. And also, because people are becoming more aware of sustainability now, some because of the love of the environment, some because of the love of their pocket. Because the more sustainable a building is, the less you are going to spend on the operational stage of that particular building. So as building become more efficient in terms of energy consumption, it becomes very important for us to consider the embodied impact of those buildings. So this one of those papers, and for those that are not from construction background, you realize there is something we call sick building syndrome, which is a phenomenon that happens when you are in a building, you just feel sick. It might be your eyes shedding tears, it might be that you just feel inconvenient tightness in your chest and several other things that happen like that when you are in building. So what I find out here is that that phenomena is going to be reduced if a building is more sustainable. So I published quite a number of papers here, dynamic relationship between embodied and operational impact of building, looking at how embodied impact and operational impact changes with the different material typology, and looking at the comparison of different material specification and building energy sources. So those are the earlier in the process. So the second phase of the research is into construction waste management, which was my doctoral research in collaboration with my colleagues then. So looking at this chart, you realize that in terms of waste, construction industry contributes about 44% of waste that goes into landfill. And when you look at how you are going to understand the significance of that is when you look at the household waste, which is just 13%. All the waste that we generate in our houses, all of them combined, contribute about 13%. But the construction industry contributes 44%. That will make you to understand the significance of construction waste management. So my research here look into how do we optimize construction processes to reduce this waste. And not just only because of the environmental impact of the waste, but also because of the cost implication. A research by BRE as far back as 2003 shows that if we can just reduce 5% of all waste generated in construction industry, the industry is going to be making 5 billion extra profit every year. So that was just 5% of all waste. So this is a significant area. This research look into development of BIM-based solution, as well as looking at the strategies, the approaches, the protocol procedure that can be used to minimize waste in construction industry. There are a lot of publications in this area, more than 20 of them, into different topics, concepts into construction waste. The first of them look into why is it that people are adopting strategies but they are not really being effective. So that is what the first study look into. And some of the key findings here is that people just adopt one strategy and they leave the other. Why it's supposed to be holistic in terms of looking at the whole solution from design to construction stage. I also look at the design strategies. What are the things that designers need to put in place to ensure that the project is not going to generate a lot of waste? Some of the things here include the dimensional coordination of the design, ensuring that you coordinate the design dimension in line with the material sizes that you are going to buy. And most importantly, designing for modularity. Modular construction is one of the key findings. I also look at the design attributes. What are the attributes of the design? When you design, what are the features of the design that are going to lead to reduce waste in terms of documentation of the design and several other elements. In addition, I also look into the competencies of the designers. What are the key knowledge that the designers should have in order to be able to support construction waste minimization? And most of the things here include the design for that dimensional coordination becomes very, very important to designer to be able to understand how materials are. Also, the material procurement. So procurement of material also contribute to construction waste. Some of the research also look into how do we optimize our material procurement to ensure that we can minimize waste. So it also includes looking into the construction strategy. What are the strategies that we need to put in place during the design to ensure that we can actually deconstruct the design, the project, the building after its end of life. So look into it holistically in that way. Site management strategy, the culture of waste in construction industry. It is observed in the research that the industry itself has that culture that supports its waste intensiveness. For instance, we have the waste allowance, which can range from 5% to 10%, which we intentionally put on the material that we are purchasing. So that means intentionally we are actually motivating waste generation on construction site. These are some of the cultural changes that are required in the construction industry to ensure that we are able to minimize waste. And another one here is the policy itself. One thing that we observe is that policy is one of the things that is actually helping the industry to be able to minimize waste. For instance, there is landfill tax, which keeps increasing every year. If you take your waste to landfill, you are going to pay some money. If you use virgin aggregate, that is new granite, gravel, and the likes, you are going to pay some money to the government because you use virgin one. So these are some of the policies that are helping. But how do we then strengthen it? So this final one that I just showed here, look at how can we strengthen the policy by introducing some carrot and stick approach. So there are some areas where we need to get penalty for people, and then that money should not just go into the government pocket, but it should also support sustainability initiative. So for this group of research into construction waste, my methodology has involved the use of exploratory sequential mixed method research. That's probably for researchers among us here. That involves the use of, you have your qualitative approaches. Qualitative approaches in layman terms, we are talking about you carrying out some interviews, some focus group discussion and the like. So you do that first, and we use these exploratory sequential approaches where we don't have a lot of priority studies. You want to know what the industry stakeholder understand about the topic before you are then going to go for a larger study. So that is what exploratory sequential mixed method approach is. Qualitative first. The finding of qualitative are then going to inform the quantitative approaches later on in the process. And also, as part of the research into waste management, I also adopted the use of structural equation modeling. So some of us will know that, and that is just some output of that structural equation modeling that is going to look at dimension reduction and ultimately being able to identify what are the key factors that actually contribute to a particular phenomena that is being investigated. And because initial research understand that we are not looking at the waste management from holistic perspective, the designer will just use the approach, contractor will use the approach. I adopted the use of system dynamic modeling, which looks at holistic impact of one strategy on the other to simulate it. So these are some of the approaches that were used, and ultimately that led to development of a design, construction, and design, procurement, and construction protocol. I won't take you through that, but generally is to look at, for you to minimize waste, these are the steps that you need to follow. And this project, because it was in collaboration with Balfour Beatty, so the largest UK construction company, so these are some of the recommendations that went to them in terms of how they can actually minimize waste. Looking at it from the design, there are key questions. If this is the case, then you do this. After you do that, go to the next, and then after the design, you go into the procurement of the material. These are the key things that you need to do if you have some responsibility. Then you go into actual construction. These are the different approaches, strategies that could be adopted in terms of the flow chart, step by step, into how you can actually minimize construction waste. It's a very useful protocol that are picked up by some, but that can still be picked up by others to minimize waste in construction. Those are the previous research that I've done. So I move into the digital construction research, which I believe is where I'm going, is where I am, and is where my research is also going. So I did this through the Construction Informatics and Digital Enterprise Lab, so which I lead with my colleagues here at Leeds Becker University. At the lab, what we do is to look into how to solve different challenges with the use of digital technology. So we have different challenges that I mentioned earlier in construction industry. We adopt the use of digital technology to solve some of these challenges. We look at the sustainable and healthy building. How do we make our buildings to be more sustainable? We look at waste. We look at the building and health. We look at air quality. So that is one of the sensors that we put in place, because that is facing one of the 300 air quality monitoring stations in the UK. So that is just to calibrate. That is just at the entrance of our Northern Terrace there. We look into modern method of construction and different approaches there. So the essence of this is to enhance productivity in the construction industry, to prevent accident, to enhance sustainability of our construction projects. And the overarching approach is the use of building information modeling, which I promise to explain to those that are not in construction. Building information modeling is just illustration of what it aims to achieve in the construction industry. Construction industry consists of different stakeholders. We have the architect, the contractor, the facilities managers, the suppliers, all of us, we need to communicate in a way. But the way we communicate before the advent of building information modeling is that this sending made to that sending made to that. When you look at that diagram, you see chaos because there is no coordination of communication among the stakeholder. But what building information modeling wants to do is what you see to the right. Everybody have that central model that we want to communicate with. We want to send information through common data environment so that all of us can have access to the same information and there won't be any mistake because of that. So through this old approach, you have a mechanical engineer designing and they put pipe somewhere. Structural engineer puts column at that particular point. You see a lot of clashes. But what building information modeling wants to achieve is to ensure that we can all communicate, we can all collaborate quite easily. And through this digital enterprise research, I've executed quite a number of projects. I think I've put 14 here. Looks like 10, but there are 3 in some places. One of them is the AutoBIM project, which I'm going to talk about. You can see the value of the projects that I've executed over the years. Time will not permit us to talk about all these projects, definitely, but I will talk about just 3 of them as time permits. You see numerous of them. You see the air quality research, 3 of them. You see the feasibility project as well, that particular one, 3 of them. Those are ongoing. Some of them are ongoing. About 5 of them are still ongoing. And I've also executed some others before these particular ones. So the first of them is the AutoBIM project, which I'm going to talk about quite quickly. So that is collaboration with Bafo Construction, White Frog. That is Peter from White Frog sitting there. So collaboration with White Frog and Bafo as well as the University of Hertfordshire. So we look into a solution, a collaborative R&D project that the aim is to ensure that people adopt building information modeling. We develop solutions for them to facilitate adoption of building information modeling. And you know, when you work with giants like Bafo it's something that is going to be very significant. So we develop a number of digital tools that are going to help construction business. That is the value of that project was £896,000. That was funded by Innovate UK. We look at some of the challenges that are facing BIM adoption, like the auto name. In building information modeling, Graham is here as well. So you have to name your files in a particular way, and you can have 1,000 of them. They need to be named in a particular way, as you can see to the top right there. So that's how it should be. So, but these are done manually, and that takes time. That is prone to error. So we automated that particular process as part of this project in such a way that with maybe 5 clicks of button, you are able to generate names of all your files that you are going to have within your Refit file. As an example, I'm going to talk about 2 elements of that has been used to solve some of these challenges in the industry. So the auto file name, so that is a paper that was written on that particular one. We also have MIDP. MIDP is also a collaborative platform where you are going to list out all the different documents that you are going to supply for a project. For a contractor, it could be thousands. For architects, it could be a couple of hundreds or a bit less than 100. And you need to supply that, and you need to do that manually, spreadsheet. So we develop a platform that automates the generation of MIDP and TIDP for organization. With a few minutes, you can generate your MIDP, especially if you have done one in the past. If you have not done one in the past, we give you templates. You can just edit it, and that will just be collaborative with other stakeholders. Others will see your TIDP, which is Task Information Delivery Plan, and with amalgamation of all the Task Information Delivery Plan is going to lead to MIDP. We also develop Carbon Calculator, which looks into embodied carbon of construction projects, a process that is time consuming, but within 20 minutes, you are able to do that instead of 2 or 3 days. So I'll start with the Carbon Calculator as an example. In construction projects, one of the things that have been required of contractors is to calculate the embodied impact of their project. That is the carbon that is embodied, to ensure that they're able to bring it down in project. This is done manually. You have spreadsheets, you extract the length and breadth, the width of the material, you extract the volume of the material, and you are then going to multiply each of them by some carbon factors. You generate it in spreadsheet, then you calculate what is the total carbon of that particular project. So it's time consuming, and when you change your design, you start all over again. So you can change your design 3 times, then you start all over again. That is very, very time consuming. So what we did on this particular element of AutoBIM project is to develop something that is going to automatically generate that embodied carbon within a couple of minutes. So that is AutoBIM carbon calculator, and we develop a material library based on ICE database. That is inventory of carbon and energy that was developed by University of Bath. So we use that inventory, and we also enable our contractor or whoever is designing to be able to put their carbon factor. If it is a new material, they can put their carbon factor. And with that, we have the library. Once you put your model, what it does is it's just going to calculate the volume of each of the material, and it's going to map it to the carbon factor automatically. And ultimately, it's going to show you some things like carbon per element. You have this aluminum, this is the total carbon. It's also going to hotspot some carbon hotspot, showing you this is the place that generates the highest volume of carbon. And then you can compare different designs to look at which one is less carbon intensive generally. So that is an example of our carbon hotspotting that was done by Betty using the tools that we developed. And as a result of that, design optioneering is possible. You can then change your design and look at the impact and compare the different designs. So from the analysis, this is what was on the construction management news some years ago about the project. What it does is it reduces the time. Something that can take you 12 hours, you use 21 minutes to do it. So looking at that improvement, that's about 3,300 improvements, and that's contributing to productivity of the construction industry. So, and again, from the design optioneering of the case study that we did, it automatically cut 14% of carbon immediately. Just do a little design optioneering. Because you see the hotspot, you can change it, then with that you evaluate it, and that reduces the carbon that is going to be generated by the project. And you can see that is from the news article. So the second one on the same AutoBIM project is the AutoBIM names, which automated the file naming. So looking at that, you can see how the names look like. For each of the files that you are going to generate, you need to name them in that particular format. So you can then imagine doing that manually, and that is going to take a whole lot of time. So what we did on this project was to automate that carbon calculator, automate that file naming. Beg your pardon. Automate that file naming within Revit as a plugin. As you can see here, you will realize that there is nothing there. The file there is no any name. But with the plugin that was developed, there are 2 options. You can use your TIDP code. You have your TIDP generator. You put your code into the system. It's going to draw all the names from your TIDP, and it's going to create just sheet for you in the right name. The next thing is just to put your drawing into those sheet of that has been generated. The other one, if there's nothing, you can as well generate that. So, and you can see here, this is where we just put the code. You put the code there, the empty code, nothing has been generated here. But by the time you put the code, you continue, and it's going to create all your files for you with the name generated in the right format. This is something that can take a whole lot of time for those that are experts in BIM. They understand what I mean by all this naming, and this is automatically generated as part of the project. So that was the first project, the AutoBIM. So there are a lot of things that were developed there, but just to pick 2 of them as key contributions that were made on this particular project. So the next one I'm going to quickly talk about is the FireBIM project. That was with some stakeholders in the industry. We have Innovation Fire Engineering. James is here as well. It's one of the wonderful projects that we carried out in collaboration with Innovation Fire Engineering. That's James. We have AnguStack, IT company that we work with, and we have P+HS Architects, a large architectural consultancy. We have Farans Construction, so a tier 1 contractor as well, that we work with on this project. So we all know that Grenfell, we know what Grenfell disaster was, where we lost 72 lives, and the outcome of this was that there's a lot of corner cuttings. When we want to look at the regulation, there's a lot of corner cuttings. People just do things because you want to check them manually. It's difficult for people to pick everything with eyes. So what we did on this project was to automate fire compliance diagnostic. So when you give your design to our system, what it's going to do is to look at it and tell you this is the area that is not compliant, this is the area that is compliant. And for the areas that are not compliant, it's also going to tell you what you need to do. Not just to tell you that it's not compliant, but it's going to suggest what you need to do on that. So we have different regulations that you can follow. But what we did on this project was to use approved document B, and we are still developing the project further. We have one that is going on, and we are still going to be developing it further. It has gone through exploitation, market research, and this is something that is going to become a business. It's just the business in the pipeline. So you have your code, put your plan. I want to use approved document B to check the design, then it's going to just show you. That is how the system platform looks like. You set it up, then you do a bit of setting, then it's going to just generate the result based on the approved document, and it's going to highlight this area is not meeting the requirement, this particular area is meeting the requirement. And it's not just going to leave you alone. Where it is not meeting the requirement, it's going to tell you this is the reason why it is not meeting the requirement, and this is exactly what you need to do for it to meet the requirement. So you can see the green one meeting the requirement, the red one are not meeting the requirement. So it's going to display the result for you based on the different section of the approved document. We have the travel distance is one of the requirements. It's going to tell you the part that are not working well, the part that are meeting, that are complying with the travel distance requirement. So that's the second one, just under the permission of time. So I'm going to jump quickly into the third one, which is the last one I'm going to talk about anyway, out of more than 20 of them that we've worked on over the years. This particular one is an ongoing project. It's called eBIM. So that is a digital BIM manager. We have the role of BIM manager. And when you ask people in the construction industry that what is the role of BIM manager, there's a lot of confusion anyway around that. So but what we are doing here is to create a digital BIM manager. When you are carrying out your BIM project, there are things that you need to do from stage one to stage last. Okay, so we have a digital BIM manager that is going to hold your hand and tell you this is the task that you need to carry out at the stage one. This is the next task. This is the next task, and that's because there's a lot of confusion around BIM itself. BIM is supposed to drive innovation in construction, but there's a lot of misunderstanding, and that's why we work with BIM consultancy, White Frog. We work with Intentech to look at how we are going to develop this solution to address some of the challenges that are facing the industry. So one of those challenges is this dummy BIM. BIM is supposed to give information. I think dummy BIM was one of the concepts that was manufactured by Graham. Graham is here. So dummy BIM. So looking at BIM is supposed to be building information modeling, but the information is going to be missing in the building information modeling. So that becomes just building models. So people assemble all this digital technology, building model, but the information that is supposed to be there so that everybody can have access to the information, everybody can collaborate, we can use that information for facilities management, will not be there ultimately. So what we did is to look at the processes, and then we look at the requirement of a BIM standard, BIM ISO 19650. We break that down, and we are developing a process that is going to help people to be able to adopt BIM, carry out BIM projects. We have the processes for them. This is what you need to do at this particular stage. This is what you need to do at this particular point. That is the interface. It's an ongoing project. We are finishing it, I guess, in June next year, and we are developing that to help people to produce the information, to know exactly what they need to produce at the different stage of their project. So those are just 3 projects that I want to give as an example of some of the works that we've done within the construction informatics over the years. And then looking ahead now, so I think you are probably going to agree with me that data is the new oil of the digital economy. So data is what is determining, is dictating whether an organization is going to prosper or whether they are going to go into administration. So we are still looking into that. That is what we do in construction informatics. We are looking at how to adopt different digital technology to solve productivity challenge, sustainability challenge within the construction industry, and also in academia as well. So one of the areas we are looking at is the BIM for Regs, which was an initiative that the government, the UK government started in 2013 that has not really made any progress in terms of looking at how to use building information modeling, how to use digital technology to check compliance of building with different aspects of regulation. We've tried with fire. We know that it can work. So we want to look at all other different elements to be diagnosing compliance. Over the years, ultimately, we've learned that collaborative research is the way to go. It's very, very important for construction industry. The industry has a lot of challenge. One organization has solution, the other doesn't. We have a lot of solution that IT industry can offer us, but we are not very good at articulating our problems. And the IT industry as well are not very good at applying those technology to solve real life problems. So that's where we stand. We have a little bit of each, and then we are then applying that to solve problems that are facing the construction industry. So the lessons from practice could be brought in by the academia, and the academia can then apply that theoretical knowledge to enhance practices. So we as academics, we are the bridges that are going to bring all these different people together. And for the sake of people that come from the industry, so a lot of opportunity in terms of collaboration with academia. Most of our fundings are things that we collaborated with different organizations. And I just put some examples here in terms of the different areas that we've explored. You look at working with us collaboratively, we develop solution for you. The solution becomes things that can solve some of the challenges that you are facing. And if that becomes a business, then that is all well and good. So there's a lot of funding opportunity, especially I put some from Innovate UK here, which we've explored over the years. And we can always collaborate with businesses to bring innovation to the table and to be able to address some of the challenges. Some of them, the organization will contribute some money, but this money can still be claimed through R&D tax credit ultimately. So it's always win-win for businesses that we collaborate with. We develop solutions, we solve some of their challenges, and ultimately we develop solutions that could be marketed. I think this is where I'm going to stop because I've been told that it has to be at this particular point. I think I've tried to bring everything under that timing. Thank you very much, everyone, for coming around.
Thank you, Professor Ajayi, for that stimulating presentation. It's most likely you have some questions or clarifications you want of him. Again, it's been a lot of work. You can see there, fantastic work, working with industry, generating income, publishing. Again, it's not every time you see something like that. It's very special. So, do we have questions or something you want to ask questions before? I don't think they want to leave you to go without questions. I don't think they want to do so. So, do we have questions you want to ask, Professor Charles?
Can I just first of all say a huge congratulations and the impact your work is having, not just for academia but for real world, and how young and up and coming researchers are beginning to emulate and see the benefits of impactful research. So that's to be commended. I was particularly interested in how BIM has moved over the years. And without naming and shaming members of the professional bodies here, and if you do shame them, I'll be the first to go out there, yeah? Where are we in terms of our professions and people coming on board in real sense to grab the benefits of BIM? I remember supervising a PhD student about 15 years ago on BIM, and I was just wondering whether the industry has taken it and whether there's a professional group that haven't taken it as more than others. Any thoughts?
Yeah, so building information modeling has matured over the years, and people begin to have the understanding as we progress. But the main challenge that I've seen over the years in terms of my research is that it seems people prefer to assemble that model without the information. The information element is still missing for most of the people, and that is where the concept of dummy BIM comes in. The BIM is supposed to be something that we are going to use to be able to have information in the model or elsewhere, so that person that is going to manage the building is going to have every information about this bulb, where was it bought, what is the rating, when is it likely to go off, and things like that. But ultimately, when the project finished, what we used to do before building information modeling was to have as built model, just to capture that information, which we are expecting BIM to then capture. But ultimately, we still do as built after the project now. We still capture that information. People are still not putting a lot of information, but few that are doing it, they are doing it really well. But it's only a few. Most of the things are probably high service. People make a lot of noise, but when you look at it, you realize that this is not really the full BIM. But there's progress, especially if it's going to be government project. You've got to demonstrate that it's BIM compliant and things like. People are trying, but ultimately we still have some ways to go in terms of what BIM is supposed to achieve. Because BIM, looking at it, is not really achieving those benefits that we want it to achieve. We think BIM is going to help us to lower the cost. Cost is lowering, but not to that point that we want. We expect BIM to help us with the collaboration. It's helping us with collaboration, definitely. It's achieving some, but definitely we still have some ways to go. Professional bodies definitely are pushing it, but not practically. Perhaps theoretically having some publications which nobody is actually using. But for organizations that are using it, I've been very fortunate to work with some organizations that are really pushing the boundary on some of the projects that we are doing. But it's not getting to the SME particularly, who are supposed to be the backbone of the industry.
Thank you.
That's what.
Okay, Professor Arif, yeah.
Well, first of all, congratulations. Sorry I was late.
I mentioned your name earlier.
Well, it's great to see. I examined his PhD. I was the external examiner.
I mentioned that, yes.
From that time, so you have come. It's really good to see the progress.
Okay, yeah.
And although we never doubted your talent back then as well, but BIM, in developing countries, so where resources are limited. It's in developed world there is more funding available, there is more resources available. But what is in ERP systems, when they came out, there was a vanilla ERP, which was the ERP system for the poor people or poor countries. What is that watered down version for BIM in the developing world? How are they doing it differently than? Are they ahead of us? Are they?
To be frank, BIM, as we look at it, is not as cost intensive as we assume. BIM is a lot. It's process driven rather than technology. It's technology, obviously, but we want it to be in a particular way. When you look at the developing country, we use Revit for design in the UK. They use Revit as well. Whether that is original, they pay Autodesk, or is crack or whatever, they also use Revit. So the same Revit, the same way we want information to be structured, they can as well structure it like that. But the main challenge with developing countries is that there's no institutional support. Unlike the UK, where government says we spend a lot of money on infrastructure, we know that if you use this technology, it's going to help us to bring down the cost. Perhaps nobody cares in the developing world whether they want to bring the cost down or they don't want to bring it down. It's just that the willingness to be able to adopt. In terms of the technology, they use the same tools that we use in this part of the world, and they can also follow the same processes, but there's no requirements. You can imagine a country that doesn't have a building regulation that works very well. You wouldn't expect them to then be thinking about building information modeling if the building regulation itself is non-existent. So I think it's just that level of development that has not reached that level. It's not necessarily cost that is hindering it. It's just the willingness from the government of all these countries to be able to adopt it. Perhaps they are not as willing to reduce costs as the UK government. It's austerity.
Okay. I think I will take two questions. Okay. 3? Any? 4? Okay, I think the way things are, there won't be any reception again. Anyway, who's going to, okay, if you want to go first, please.
Thank you very much, sir. We appreciate it. My question kind of cuts across the area of knowledge transfer. I'm more particular about that because I do not necessarily want you to go with everything. I would like some people like myself, young researchers, recent graduates, current students, I'd like to know what platforms or what developmental facilities we could start initiating, where we could begin to do the kind of things you're currently doing, and give it like 5 years from now, we can begin to give, sessions like this. So, apparently, I'm not trying to fast track everything. It takes time. I'm just saying we can begin to look forward to doing things like this in the near future.
Okay.
So, what are the platforms or developmental opportunities for research and development that you could tell us about?
Okay, so I think the first thing is you get supervisor like mine first, yeah. Like I mentioned earlier, so that is where the journey starts. But jokes apart, is not magic, it's not miracle. You see, there are different ways from what I've learned, different ways to progress, and I will divide that into 3. The first is you follow the trend. What is the thing that people want, and you just follow that. The second thing is you become controversial. If you become controversial, then people will begin to hear you out. So just become controversial. Just tell people that digital technology is madness. You should not be using mobile phone. People will hear you out. So that is another way to go. The third way probably is just to stay in between. But most importantly is just to know what interests you, what is the trend there. If people are interested in a particular thing, then you just make sure you align your research with that particular area. That is possibly what has helped me in my career, apart from having great mentor, great colleagues that I've worked with, and also the people that have been my collaborators over the year. So just understand what people need that is going to solve that real problem. In the past, we used to tell students, don't take out your phone in class, don't use that, don't use this. But now, we actually use that phone as part of lecture. So you know what is the current trend, what is the latest development, and you just adopt that approach. But get a mentor. That's very importantly.
Okay, the gentleman there.
Thanks.
Yes, please.
All right. I feel very fortunate to have Professor Saheed Ajayi as my supervisor for my project, and along with Cheerful here. Of course, BIM's just not about buildings. BIM's about infrastructure as well, and there's massive projects in the country that's developing its own route using BIM in infrastructure. How do you see the differences in the challenges between the 2 sectors?
To be frank, most of my research are focused on buildings. I don't know much about the infrastructure. I know your project is about infrastructure. I don't do much with the infrastructure because mainly because the kind of tools that are used in the infrastructure sector are different from what we use in the building sector. So because of that, I just keep my mouth where my money is. So just to focus on the building. I focus on building. You use Revit, but when you are dealing with building, but when you are designing your roads, you see there's a lot of jargons that you told me throughout your PhD that I don't, redlining, all those different things that I've learned through your project. There are things that I don't know and I don't want to know because I just want to focus on the one that I'm doing because there's a lot of problems that I can address. I think I have enough problem than to come into that infrastructure. I will leave that to you. For people that might not know, when you mention BIM in highway infrastructure in the UK, just search online. Graham is the first name that you are going to see when it comes to BIM in infrastructure. So I will leave his problem to him.
Okay, Mark, and then I will come to Stanley. Mark, please.
Firstly, congratulations, Saheed.
Thank you,
well
boss.
done. Excellent hard work and an excellent presentation and very engaging. The thing that I'd ask you is, your focus is on BIM and it's on the development, the construction phase process of it. Do you think if we focused on the final user, the occupier of the building, and the benefits that BIM could have to them, that would drive the uptake of BIM within the construction industry faster than trying to get the construction industry to highlight the cost savings and the carbon savings that it would make?
Yeah, so the essence of BIM is to benefit the end users. But the main problem is when you are constructing, for instance, when you are designing a building, or you are the owner of the building, and you are not going to live there, you are probably not going to put the same finishing that you are going to put if you are going to live there. People don't care about who lives there. Contractors want to make their profit and go away, and designers want to make their profit and go away as well. But things are changing with the introduction of golden thread and all those different things that you need to become accountable even 30 years after the project finished. I think things might be changing. But the introduction of BIM itself was driven by the fact that when the building is being managed, facilities management phase, then how are we going to manage? How do we ensure that we put a lot of information into the model to help them ultimately? That was the driver. But everybody wants to make their profit and just go away. So that is probably the challenge. And unless there's more of an institutional willingness from the key driver, which is the government, it's probably going to be like that. People just for profit. People want to make profit and go away. So that's the main challenge.
Okay, I think the final one will come from Sterling, and then we'll put a stop to it.
Yeah. So there's an international conference happening today in London, I think, about artificial intelligence. So you've done a lot of work on BIM. How could AI help you to solve some of your problems?
Yeah, so we've also done a lot of research with AI as well. For instance, one of the projects that we are doing now with Innovation Fire Engineering is to look at this building regulation. How do we use AI to just read it, to code it, and to be able to put it behind our system to drive our compliance diagnostic. We also look at how we can look at the non-conformance reports. When you construct a building, our contractors are responsible for writing down their non-conformance report, which is like, we made mistake here, we changed it, this was the problem that happened. We look at that, we codify it, we use AI, and through that we develop a solution that you can put your model in, and it's going to be able to tell you, and with the information that I have, this is likely to lead to trouble when you are constructing this building. We've been adopting AI to solve some of the challenge. We also look at the risk as well. When you are constructing buildings, it's going to highlight the areas that could lead to safety issue, some challenge, some risk. So we've been applying AI on different projects, but I just mentioned some examples of them, and not to take our time. So AI is very, very important. Whether we agree or not, AI is the future. So when ChatGPT came, all of us in the university, we became disorganized. We are still disorganized up till now. We still don't know. When you read reports, the university will tell you about plagiarism, AI. When you read it from beginning to the end as a lecturer, you will ask yourself, what is the conclusion? So we are all confused. AI is definitely here to stay, and we've just got to adopt it and be able to live with it and be able to benefit from it. So we are adopting it and we are using it in our different projects.
I think thank you again. Let's put our hands together. I think that is now finished. Now you can now move on to do something else, yes. Obviously. Again, thank you everyone for coming. It's been a great night having you here at Leeds Beckett University. Hopefully, we continue to work with all our employers that are here, the partners. Some of them, they are here. We will continue to work with you. And also, we have some friends of Saheed and his family as well. They are here. Again, thank you for coming. And we have some students as well. Again, you are asking the right question. How do you move from where you are to where he is? Again, it's the right question to ask. Again, thank you everyone for coming this evening. I'm sure you've had a nice time coming to Leeds Beckett University. This is what we do here at the university. There are opportunities in terms of research at the university. And also we have a lot of programs running through the school as well. If you are interested, please come and speak to one of us. We'll be willing to engage with you in terms of what we do. Again, thank you for coming. And I've been told we have reception downstairs. Yeah. Again, please, I think we need to do that as quickly as possible before everything is taken. Again, thank you everyone. Thank you.